Have you ever pondered the origins of Saturn's rings, those celestial halos that have mystified us for eons? Let's take a journey back in time, millions of years ago. Picture a moon, one of Saturn's very own, or maybe a passing comet. Now imagine, this celestial body strays too close to the gas giant. Saturn's immense gravitational pull starts playing tug-of-war with it, and eventually, the celestial body succumbs, torn apart by the overwhelming forces. This cataclysmic event left a trail of debris, a cosmic graveyard if you will. The remnants, composed mainly of ice and rock, were captured by Saturn's gravity and began to orbit the planet. Over time, these pieces started to cluster and form what we now know as Saturn's rings. The process wasn't as simple as it sounds. The debris didn't just neatly line up to form these rings. The process was one of chaos and collision. Pieces of the shattered celestial body crashed and collided, breaking into smaller and smaller pieces. These fragments then spread out into a flat, thin disk that encircles Saturn. Interestingly, Saturn isn't alone in this ringed phenomenon. Jupiter, Uranus, and Neptune also have ring systems, albeit less prominent. However, Saturn's rings stand out for their complexity and sheer beauty. They are the most extensive ring system of any planet in our solar system. But why are Saturn's rings so bright, you may wonder? It's because they are primarily made up of ice. These icy particles range in size, from tiny grains to massive chunks as big as a house. The ice reflects sunlight, causing the rings to shine brightly, making them easily visible from Earth. The formation of Saturn's rings is a story of destruction and creation, a cosmic ballet of gravitational forces. It's a testament to the dynamic and ever-changing nature of our universe. So, these rings we see today are essentially the ghostly remains of a celestial body that met an untimely end. And that's just the beginning of the story. There's so much more to Saturn's rings than meets the eye. But for now, let's marvel at the beauty of this cosmic spectacle, a testament to the fascinating and complex processes that shape our universe. Now that we know how Saturn's rings came into being, what are they made of, you might ask? The answer is both simple and fascinating. Predominantly, the rings consist of water ice. Yes, you heard right. Those stunning rings that create a mesmerizing halo around Saturn are chiefly composed of chunks of ice, ranging in size from tiny dust particles to colossal icebergs. But ice doesn't tell the whole story. Lying beneath the icy facade is a mix of rocky material and dust, adding depth and complexity to the ring's composition. These elements, though small in proportion, play a significant role in the formation and maintenance of the rings. Now let's delve a bit deeper into the structure of these rings. Far from being a single solid ring, Saturn's halo is divided into several distinct ringlets. Each ringlet is a world of its own, with its unique blend of ice, rock, and dust. These ringlets are segregated by gaps, some of which are caused by Saturn's moons. The interplay between the moons and the rings results in a dynamic and ever-changing system. So, while Saturn's rings may appear to be a simple, ethereal halo from afar, a closer look reveals a complex and structured system. Their composition of predominantly water ice combined with rocky material and dust, and their division into several ringlets, make Saturn's rings one of the most intriguing features of our solar system. Despite their ethereal appearance, Saturn's rings are a complex and structured system. Saturn's rings continue to puzzle and fascinate us. What are some of the most intriguing finds so far? The rings of Saturn, while undeniably beautiful, are also a source of great mystery. One of the most puzzling phenomena we've encountered are what's known as spokes, ghostly radial markings that appear and disappear on the rings. First spotted by the Voyager missions in the 1980s, these spokes are thought to be composed of microscopic dust particles, but their exact nature and cause remain elusive, adding another layer of intrigue to Saturn's rings. Then there's the curious case of the F ring. This outermost discrete ring of Saturn is marked by a complex structure that's constantly changing. It's a narrow, twisted ring, often described as braided. Scientists believe that this peculiar structure is maintained by two of Saturn's moons, Prometheus and Pandora, which are known as shepherd moons. Yet exactly how they manage this feat is still a subject of ongoing research. And let's not forget the revelation brought about by the Cassini mission. Launched in 1997, Cassini spent 13 years exploring Saturn and its environs. Among its many discoveries, perhaps the most astonishing was the detection of complex organic molecules, the building blocks of life, in the icy plumes of Enceladus, one of Saturn's moons. This finding has profound implications not just for Saturn and its rings, but for our understanding of where life could exist beyond Earth. Another of Cassini's revelations was the age of Saturn's rings. It was long believed that the rings were formed around the same time as Saturn itself, approximately 4 billion years ago. But data from Cassini suggests that they might be much younger, maybe just 100 million years old. If this is true, it means the rings could have formed when dinosaurs roamed our planet. These discoveries only deepen the enigma of Saturn's rings, beckoning us to probe further. With so much left to uncover, what does the future hold for our exploration of Saturn's rings? Well, buckle up, space cadets, because we're in for an exciting ride. As technology advances at a breakneck pace, we're developing new tools and instruments capable of delving deeper into the mysteries of these cosmic halos. In the pipeline, we have missions armed with state-of-the-art telescopes and spectrometers to probe the composition of Saturn's rings with unprecedented precision. We're also designing spacecraft that can withstand the harsh conditions of the Saturnian system, enabling closer encounters, and perhaps even a landing on one of Saturn's icy moons. And it's not just about the hardware. We're also refining our computational models, harnessing the power of artificial intelligence to predict and analyze the intricate dance of particles within the rings. As we look forward to unearthing more secrets of Saturn's rings, we stand on the precipice of exciting new discoveries. From their formation to their future, Saturn's rings are a testament to the wonders of our universe. We've delved into the birth of these celestial bands, explored their unique structure, and unearthed some of their captivating secrets. We've also peered into the future where further exploration awaits. As we continue our cosmic journey, Saturn's rings remind us of the limitless possibilities that lie in the world beyond our own.